So for today we are going to understand the concepts of neural network representation, problem faced of neural networks, multi-layer networks, and the backpropagation algorithm. So for these concepts form the foundation of deep learning and modern artificial intelligence. Okay, so this is the answer for the previous video's question time. So you have to refer it, and then if you have any doubts you have to clarify this. Okay, so let's start our artificial neural networks. So artificial neural networks are computational models inspired by the biological human brain. Okay, so it's just like biological neurons receive signals, process them, and pass them forward. So artificial neurons also receive inputs, apply weights, and generate outputs. Okay, so first it will be receive the inputs, and for the inputs it apply the weights, and then it will be generate the outputs. Okay, so neural networks are mainly used for solving classification and regression problems. Okay, so this is the structure of the artificial neural networks. Okay, so for here we have a input layer, and then hidden layer, and then network output layer. Okay, so for input layer, in the sense it will be getting it receives the data. Okay, and then hidden layer, in that hidden layer again, so that input layer, this is where the network receives information. For example, in an image recognition task, the input could be an image. The hidden layers, these layers process the data received from the input layer. The more hidden layers there are, the more complex patterns the network can learn and understand. So for each hidden layer, transform the data into more abstract information. So it will be passing to the information, it's like a abstract information. So why they were mentioning in abstract information? In the sense, in that hidden layer accepts more input layers. So for the hidden layer, it's processed a complex patterns, so it will be processed like a complex patterns. So for the network, it can learn and understand the concepts. Okay, so for on the whole we need a output only, no? So for that purpose it will be produce only the output for us. Okay, the next one is output layer. So this is where the final decision or prediction is made. For example, after processing an image, the output layer might decide whether it's a cat or a dog. Okay, so the next one is how the artificial networks working. So we already discussed about the layers, no? So the artificial neural networks work by learning patterns in data through a process called training. So during training, the network adjusts itself to improve its accuracy by comparing its predictions with the actual results. Okay, so for it will be the data will be through a process, it's called a training. Okay, so for example, we will give the training to the input layer. Okay, so the input layer getting the training. Okay, this is the output layer, we have to give it to the users. So like that it will be produces the output. Okay, so we already discussed about the three layers: input layer, hidden layer, and then output layer. Okay, the next one is training and testing. So for first we will give the training to the data, and then we have to testing to the data. So once we have to give it to the training, means they know this data is from the this information. So like that they will be know it. So based on your training only, the testing will be, that means the result will be, you have to get it. Okay, the next one is problems of neural networks. So what are the problems we have to face to here in the sense? So even though neural networks are powerful, they have some limitations. So for first, they require a large amount of training data. Okay, so first it will be need a large amount of training data. The second, they are computationally expensive, and then third, they are difficult to interpret. This is called the black box problem. Okay, the next one, fourth, deep networks may suffer from vanishing gradient problems. So for these four are the main problems of the neural networks. Okay, next one is multi-layer networks. Okay, so a multi-layer network contains one or more hidden layer. Okay, so it is called a multi-layer perceptron or MLP. Okay, multi-layer perceptron learning. Okay, so hidden layers allow the network to learn complex non-linear relationships. So for here we have to give a training to the hidden layers to allow the complex, that means a difficult process also it will be process it and then give the output. So like that we have to give the training to them. Okay, so this is why multi-layer networks can solve problems like XR. Okay, so the next one we have to already discussed about the input layer, hidden layer, and then the output layer. Okay, so the hidden layer, input layer in the sense we knows about. So it's extract, that means the first layer detects the edges, and then the second layer detects the shapes, and then the final layer detects the complete objects. Okay, next one is working of multi-layer perceptron. So for here we have to see the how it will be working a multi-layer perceptron. Okay, so they have some key mechanism, so such as forward propagation, loss function, back propagation, and optimization. So for this session we have to discuss about forward propagation and then back propagation. Okay, so forward propagation. So what is a forward propagation? In forward propagation, the data flows from the input layer to the output layer, so passing through any hidden layers. So each neuron in the hidden layers process in input. So how it will be processed? So that's why here we have to use the some weighted sum. Okay, so weighted sum, the neurons computes the weighted sums of the inputs. So for what is the input values, we have to get it in the sense the wi, it's corresponding the weight. The wi is corresponding the weight of the input values, and then xi is the input values. So what are the values we have to give it to know? So that is the input values. In that input values, weight is stored in the wi, and then b is the term of bias. Okay, so and then these are all will be stored to the z. So in that z is called the net input to neuron. Okay, so in each neuron receives multiple inputs. So every input has a weight attached to it. The neuron multiplies each input with its weight. So for both of that means input and then the weight, it will be multiplied, and then it will be added to the values together. So finally it adds a bias term. So basically in that z equal to summation wi xi plus b. So for here weights are more important. Why? Because of weights only decide the outputs. Okay, so if a weight is large, the input has more influence. The weight is small, the input has less influence. So here why we have to use a bias? So why we have to use the bias? In the sense bias shift the output. Okay, so without bias the model may not fit data in the activation function and then loss function. Activation function. So after calculating z, we apply activation function. So a equal to f of z. So that is the activation function, where a equal to output of neuron, f of z equal to activation function. Okay, so for here we have to use the the weighted sum z is passed through an activation function to introduce to introduce non-linearity. So common activations include, so for sigmoid, rectified linear unit, and then hyperbolic tangent okay, tangent. Okay, so for first sigmoid, so sigmoid, in the sense, so we have to use the sigmoid curve is, no, we already studied about in the linear regression. So the curve is there, no, so that is called a sigmoid function. We already discussed that one in a last session. Okay, so for here we have to use the delta z equal back propagation. Okay, so why we have to use a back propagation here? In the sense, it will be calculating for the gradient calculation. So the goal of training an MLP is to minimize the loss function by adjusting the network weights and biases. So it will be adjusting the networks of the weights and then biases. So this is achieved through back propagation. Okay, so the gradient calculations, the gradients of the loss function with respect to each weight and bias are calculated using the chain rule of calculus. Error propagation, the error is propagated back through the network layer by layer. The gradient descent, so the network updates the weights and biases by moving in the opposite direction of the gradient to reduce the loss. So for here we have to use the algorithm W equal to W minus N into delta L divided by delta W. Okay, so where we already knows W means it's a weight, and then N is the learning data, and then delta L divided by delta W is the gradient of the loss function with respect to the weight. Okay, so now here we have to use the eta, so it will be a learning rate. So this is called the eta. So in this eta is called the learning rate, and then delta L divided by delta W is a gradient. So how error changes with the weight. So what does this mean? In the sense, if increasing weight, it is the error. Okay, so in that if increases the weight, it decreases the error, and then the gradient tells the direction of steepest increase. So back propagation neural network. So for here we have to, so the back propagation of errors is a key algorithm used to train neural networks by minimizing the difference between predicted and actual outputs. So for here it will be going to predicted output minus actual output. In the sense, we will get a error, no. So in that error, how it will be getting, and then how we have to reduce that error. So that's why we have to use the back propagation algorithm in neural network. Okay, so it works by propagating errors backward through the network. So using the chain rule of calculus to compute gradients, and then it iteratively updating the weights and biases. Okay, so the next one, forward pass work. So for working of back propagation algorithm, so for here we have to see in the forward pass work. So the input is passed through the network to get the output. Okay, it will be forwarded. It will be passed to the forwarder. In the sense, it will be going like a forward pass work, and then backward pass work. In the sense, the error is propagated backward through the network. In the sense, that is called a backward pass. Okay, so for here we have to how it will be predicted the MSE. In the sense, so MSE is nothing but mean squared error. So how we have to getting a mean square error? In the sense, predicted output minus actual output of the whole square, we have to get in a mean squared error. Okay, so this is the question time. I have to know the answers for this. So the next class we have to discuss these answers. Okay, so you have to rectify these questions answers, and then refer this video and then give the answer to these questions. Okay, thank you. Next class.